So, so just to talk a bit more about the manufacturing stack and what it looks like today, and where we think it's actually going to be changing and where it's going. So really today you're obviously dealing with the Purdue model levels 0 through 5, where it's a very linear approach by design, where each level has to communicate with one another. It's a very big mix of complex, disparate technologies that really don't communicate together very well or across levels. There's no really way to actually really enable this. So as you're dealing with a lot of organizational silos of data, silos of information. There's a lot of spreadsheet or tribal driven type of recording of data or information that's taking place, or it's being stuck within even some of the most important engineers have access to some of the process and how they actually make some of these products or how machines are configured. It's very much of a tribal knowledge that takes place in some manufacturing plants. So really actually dealing with downtime and risk as well. Everything is driven through more of a manual approach. So the smart manufacturing platform of today, this is what it looks like to us, where it's deployed at the edge within the four walls of the factory. So you don't have to worry about anything regarding cloud or security issues that companies are still pretty apprehensive when it comes to manufacturing. And it's really one platform that can communicate across a wide variety of assets and systems, whether it's PLCs or controllers, robotic systems, or OT systems like SCADA systems, as well as now communicating to the cloud. So whether that's dealing with now cloud communication or big data, and everything really needs to work together. So it's really an anywhere to anywhere type of approach for data movement. And it really shouldn't be about starting everything from scratch. It's really about building on existing investments. So bridging this gap of data, but also providing intelligence, pre-processing of data in between, and really bridging this OT to IT divide, which has been a big challenge now for trying to get some of these projects underway. So step one is really a data connectivity challenge. We're dealing with a lot of siloed ecosystems of data that have been trapped inside of control systems now, whether it's and inside of various automation vendors as well. They all have their own proprietary protocols, ways of communicating, data format structures. So it's very difficult to actually make sense. First of all, collect this data, but then make sense out of this data as well. So having a secure, normalized common data layer that can essentially communicate across everything on the factory floor is a necessity before you can even get started with anything further from that point. Step two is really around data intelligence. So once you have access to this data, how you can pre-process or process this data at the edge, how you can actually drive analytics on top of this data at the edge, how you can do local visualization or KPI dashboarding, as well as deploy applications that have been created either in-house or from third-party organizations where you can get value with the same data. And then the third step is really bridging this OT to IT gap. So integration of data. This is now integrating some of this OT data to IT systems. So whether it's cloud-based systems or big data platforms or enterprise type systems, being able to seamlessly integrate this data to systems and applications that can get further use out of this data or to the cloud for longer term process and storage and analytics. So the Litmus approach, we are coming from a product type of approach. So we're purely a product company. Litmus Edge is really our core product that we've built. So it's really sitting at the edge computing layer. It's installed on a gateway or industrial PC, or it can be installed inside of a virtual machine as well on a local server in the factory. And what it provides from the first point is everything needed in terms of data collection across any type of asset, the ability to normalize that data, the ability to analyze that data, and then integrate that data out to systems that can leverage that data. Then we have the Litmus Edge Manager. So this is more of the edge management layer. It's deployed in the cloud or on premise. So the customer can actually install it in their own infrastructure. So they have complete control and access over the system. And it's really providing everything needed to remotely manage any type of edge computing device, the ability to centralize the data, as well as manage the deployment of applications from the cloud or a central system down to these edge nodes. So just to dive into a bit deeper, what Litmus Edge really provides is these three core buckets across edge connectivity, edge intelligence, and integration of data. So once you install Litmus Edge, and you'll see this clearly when we go through the demo later on, but everything is user interface driven. There's really no coding required. It's very configuration based. So from the first point here, when you're looking to connect to your assets, what we've done is we've pre-built hundreds of different protocol drivers to speak to almost anything that's out there on the plant floor. So out of the box, we can connect. And then from that point, we can define the data points that we want to collect. And what we do is we normalize all of that data. So we put all of that data into a standardized JSON format. We follow standards like IPSO data format, which is a standardized JSON, and it's adding as well additional metadata to the data model. And then now you have normalized data. So for example, if you're collecting data from a Rockwell device or of a Siemens device, we'll output that data in the same format and structure. So then now it's more easily usable and consumable by applications or systems. Then we have a time series database. So this time series database can store some of this data as well as make it available to internal components inside of Litmus Edge or push it out of the system. So in terms of now driving intelligence, what we've done is we've built an analytics engine that has that can pre-calculate over 20 different manufacturing KPIs. So if you're looking for things like OEE out of the box or asset utilization, uptime, there's over 20 different KPIs that are available, as well as different statistical functions that can be used to analyze this data. So things like anomaly detection or change of value. These are all readily available inside of our analytics engine. We have a alerts and workflow engine, so a drag and drop interface for setting up different types of rules, alerts around the data, if and then kind of analysis, filtering of the data. So all the data can be pre-processed, filtered, as well as actions and thresholds can be set up. And then we have a solutions marketplace. So what we're doing here is essentially hosting and managing a series of Docker containers and applications inside of Litmus Edge. So we preload a marketplace with about 45 applications that can be readily used, like different types of databases or visualization tools. So if you wanted to visualize or trend some of these KPIs or raw data as well as different types of machine learning tools. There's various applications that are available from the marketplace. Or if you've created some of your own in-house applications, you can actually create your own private marketplaces. And as an organization, you can now centrally host these applications inside of one edge platform and make all of this data available and deploy those applications at the edge. We also provide runtime for machine learning models. So if you've developed some models in the cloud, now you're looking for a way to actually run these inside of a real-time edge platform. These can be deployed inside of Litmus Edge. So now as we collect the data, we can feed it into these models and take decisions based on the machine learning model. So whether it's sending commands back to the devices. So everything is bidirectional. We can update variables in the PLC. We can turn off the PLC and stop the machine, for example, if it's hitting a critical threshold. So everything, all the communication is bidirectional. This does not have to be leveraged. Some companies are a bit apprehensive about PLC control being pushed back towards it. So that's something that by default, it can be disabled as well. And then we provide the IT integration. So now streaming data up to any cloud, big data platform, ERP system, data lake. So we've pre-built integrations for whether it's AWS, Azure, Google, Cloudera, various big data platforms, different enterprise systems like SAP, so that out of the box, we can push data to those systems, as well as we have a full-fledged OPC UA server to publish this data out through a standard OPC UA interface, as well as other protocols like MQTT, for example, or some of our RESTful interfaces. And then we have the Litmus Edge Manager. So as I mentioned, this is deployed at the central level. So it's running in your own instance of Azure, AWS, Google, or it can be running on an on-prem server in the plant as well, or a local data center. And what it's really providing now is the ability to centrally manage multiple Litmus Edge nodes, whether they're across one factory or multiple factories. So everything from being able to remotely collect all of this data, integrate it from one interface to your cloud services or applications, as well as being able to remotely manage all of these Litmus Edge nodes. So everything from being able to remotely configuring these devices, doing over-the-air updates, creating templates. So if you've configured, for example, one Edge node to communicate to one production line, if you have the same production line which has the same type of setup, we can then deploy the same configurations to hundreds or thousands of Edge nodes at once. So that really helps companies scale more effectively and have complete control over how you can actually not only deploy this on one machine, but across thousands or tens of thousands of machines. You can also manage all of your public or private marketplaces. So creating various marketplaces and then centrally deploying them down to run on the various Edge devices, and then orchestrate your applications from the cloud to the Edge. So as you create applications or machine learning models in the cloud, now they can be deployed down to run on the Edge devices, and you can have central control over everything from the Edge manager. So essentially this becomes your single pane of glass where you can now remotely manage all of your Edge deployments now across many different facilities around the world.